Hello everyone, welcome to my channel on Learning Field. Today we'll discuss about chapter 2 of class 12 physics from Ncert book, that is electric potential and potential energy. If we are going to learn about electric potential energy, then first of all we need to learn about some of the examples here. Okay, suppose we know that potential energy is denoted by U. Suppose U is equals to, example is given here, uh, point charge and test charge. The distance is r, so we can write, so U is equals to kq by r. Potential energy is equals to, comma, U is equals to kq by r. Okay, another example is also given here. Suppose this is the point O and this is the point P in space. That means, suppose in air. Okay, the distance between them is r1 and this is the point q1. So we can write electric potential. We know that electric potential is denoted by V, so V1 is equals to k q1 by r1. This is the formula of electric potential of q1 at P. Suppose another example is also taken here. The distance between the point to the q1 is r1, q2 is r2 and q3 is r3. So we can write electric potential as V is equals to k q1 by r1 plus k q2 by r2 plus k q3 by r3. This is the formula for writing the electric potential. There is a big difference between electric potential energy and electric potential. Electric potential means some of the positions. Suppose there is a charge which has electric fields lines and this is the point position. There is a position, that means electric potential. And electric potential energy means, suppose there is a word energy, isn't it? So there will be charge plus and another charge plus, that is point charge. These are the electric field lines. And if you are going to learn about the next topic, that is electrostatic potential. Since we have learned about electrostatic means study of electrons at rest. And potential means what? Potential means which has the ability, that means which has the tendency. Okay, now this word electrostatic potential is defined as the work done per unit positive charge. That means we can write in the formula like this: work done per unit positive charge plus q. We can write electrostatic potential as W by plus Q. This is the formula for electrostatic potential. Okay. Now the next topic is, we are going to learn about the charge. Suppose this is the charge and this is the green arrows. Suppose this is the green arrows. The darker the green arrows, the stronger will be the electric field. Okay. Now to move the charge against electric field, work must be done on the electric field. Okay. Suppose we are moving an object from point A to point B, work must be done on the electric field. That means to move the object from point A to point B, work must be done. Otherwise, there will be no any charge against the electric field. Now, V is equals to voltage is equals to electric potential. The potential, if you are going to define about the potential difference, then we can define like that: the potential difference VV to VA or delta V is the work done per unit charge necessary to move a charge at constant speed from point A to point B. That means potential difference is defined as the work done per unit charge. This is done work done per unit charge. Potential difference means what? Work done per unit charge. Now one necessary is that it should be at constant speed. That means from point A to point B. Suppose V along is just the electric potential at that point, just like potential energy, that is gravitation. It is only the change in potential energy that is measurable. In other words, you can only compare potential energy from one point to another. Often we use the art as potential energy is equals to 0 to make a reference or starting point. Now, what is electric potential? This word is very important in this chapter. Electric potential. Electric potential means what? We define electric potential by charge by, that means potential energy by charge. The potential energy per unit charge, potential energy per unit charge is the electric potential. There is a big difference between electric potential and potential energy. Now the next topic is both electric potential and potential difference, both potential energy, sorry, both electric potential energy and potential difference are scalar quantities. That means they're scalar. Now the next is the potential is characterized of the field only, independent of the value of q naught, and has a value at every point in an electric field. As a charged particle moves in an electric field, it will experience a change in potential. That means if a charged particle moves, electric field will experience a change in potential. We can denote like this: delta V is equals to delta U by Q naught. So we can write it as minus of integration of A to B EDS. So moving in an electric field, strength causes changes in potential. That means strength causes changes in potential if a electric field is moving. So E average we can write delta V by D. So delta V, if we cross multiply this one, delta V is equals to ED. Now it will be logical to set up a sign convention where delta V is positive when a test charge gains potential and negative when it moves like against the electric field. Moving against the lines will be gain of potential. Moving against the lines will be gain of potential, like compressing a spring. So if you write delta V is equals to minus ED, this doesn't work. So instead we can write E average is equals to minus delta V by D. Okay. Now the next topic is electric potential difference. If you are going to define about the electric potential difference, we note down that the electric potential difference between an initial point I and final point F can be expressed in terms of the electric potential energy of Q at each point. So we can write delta V is equals to Vf minus Vi, that is final minus initial. So directly we can write that delta U by Q. Okay, hence we can relate the charge, the change in electric potential to the work done by the electric field on the charge. Okay, so we can write delta V is equals to minus of W, that is external, by Q. External work is done here. Okay, so this much for today. Stay tuned for the next video. Thank you.